Here are the solutions to that Chicago free response questions, problem number 6. So here we're given that f is a continuous function that's graphed above here on the closed interval from -2 to 3. The graph of f consists of a semicircle and a semi-ellipse as shown above here. And we're going to let g of x equal the integral from -2 to x of f of t dt. So question A, on what intervals, if any, is g concave down? Justify your answers. So we definitely want to make a point that g prime of x is equal to f of x. Then also that g double prime of x would equal f prime of x. So I'm going to answer part A up here. A lot of times we're going to restate these in our explanation. So we know, again, g is concave down when g double prime of x, which is equal to f prime of x, is negative. How does this relate to the graph, or how do we read the graph for this? We're looking for tangent lines with negative slopes. So our tangent lines start to have negative slopes from x equals -1, and even over here, and it looks like halfway between. So this occurs from -1 to 1.5, or 3/2 here. Or you could write an inequality. All right, question B. If the equation of the line tangent to the graph of g of x at the point where x equals 0 is y equals mx plus b, what is the value of m and the value of g of 0? Justify your answer. So for part B, we need the slope of the tangent line. That's the slope that's right here, m. And we know if we're doing looking at a tangent line to the graph of g of x, then that's equal to g prime of x. So at x equals 0 means g prime of 0. But remember, g prime of x is equal to f of x, so this is equal to f of 0, and we read the graph to figure this out. So f of 0 is 2. So the slope of our tangent line is 2. And then we need the point. We need to know what g of 0 is. So this means it's the integral from -2 to 0 of f of t dt. So how do we use the graph to help us out here? This is the area between the curve and the x-axis. So if we look from -2 to 0, we have a semicircle, but we also have this portion down here. So if we wanted all this area, we're going to take a semicircle and then this rectangle here. So this becomes the area of the semicircle plus the area of the rectangle. So then we're going to get 1/2 pi r squared. So the radius of the semicircle is just 1. And then our rectangle measures 2, but actually a square, 2 by 2. So we get pi over 2 plus 4. All right, and that's all we were asking for here. What is the value of m? What is the value of g of 0? So actually assigning the point values here. Part A was 2 points, 1 point for stating this relationship, 1 point for the answer. Part B was nice, it's 4 points. 1 point for stating this, 1 point for that answer, and 2 points for all of this. Now let's take a look at C. If the average value of f on the interval from 0 to 3 inclusive is 0, find the value of g of 3. Show your work that leads to your answer. So we want to be thorough here. So we want to write out the formula and always label what it is you're calculating. It's the average value, which is equal to 1 over b minus a times the integral from a to b times f of x dx. Or in this case, f of t dt. We could write it that way. actually going back, it is the average value of f. So we're right to think of it as f of x dx. Because now when we take the antiderivative, we'll get g. So then this becomes 1 over, so we're going from 0 to 3, so 3 minus 0 times the integral from 0 to 3 of f of x dx. This becomes 1/3. So again, the antiderivative of f of x is going to become g, so we'll get g of 3 minus g of 0. Now we know they told us the average value was 0, so we'll substitute the 0 in here. So then we get 0 is equal to 1/3 of g of 3 minus 1/3 of g of 0. So if we multiply everything throughout by 3, we just get 0 is equal to g of 3 minus g of 0, which means they need to equal each other. So g of 0 is equal to g of 3. And that was equal to pi over 2 plus 4. So how many points for this? Should be just 3 more. So 1 point for showing this, 1 point for showing this, and 1 point for the answer.